Hello, everyone. Welcome to Geeks for Geeks. I hope you all are having a very good learning journey with this Habit Builder series. So, for beginning, let's first talk a little, and then after 2 minutes, we'll be jumping on to the topic. Talking about today's topic, it is going to be graphs, and I'll be waiting for the regular audience that I have here for them to reply me. And once every acknowledgement is here with me, then I'll be proceeding. All right, guys, let's just rate the series that we guys are doing. Okay, the 21 days habit builder series out of 5 again. Okay, if you want to give a rating to this series, because we have come halfway through. Today is day 12. We are going up to the 21st day. Hello, Srinivas. Good to see you again. Siddharth, good evening. Money is there. Okay. Siddharth, by the way, is your Sid, sir. Sid bhaiya. All right. So let's see. I'm waiting for a little more replies. All right. Ayushi has rated the series to be 4. Until then, till we are starting, you can tell me like we have gone past to 11 days. How have these days been to you? How the learning journey has improved or it is still the same? We are talking about building your habits. So have you started getting the habit of coding? Okay. Ayushi is one of the regular person. Srinivas has been with the very first day, from the very first day. And Bhanu is here. Hello, Bhanu. Hi. All right. So let's talk about yesterday's topic a little. How was yesterday's class, and did you understand everything? Did you understand all the three questions yesterday? Hello, Vicky. Good evening. Prateek is back. Hello, Prateek. I was waiting for you. So we'll be beginning soon with graphs. Don't worry. All right. Let's begin. Okay. So the prerequisite for this stream is going to be that you should be well aware of how the logic of DFS and recursion is working. I hope all the people who have been following the series are already clear about that. But even if for the audience who might have newly joined to this video only, they should be having a little knowledge about recursion and how DFS works. Okay, and they are good to go to learn graphs ahead. Hello, Ramchandra. I remember you from yesterday. All right. So should we begin? Plus one in the chats to begin. All right. Got the acknowledgement. Okay. So before just jumping onto the questions, today I would like that if we can discuss a little theory about graphs, know how graphs work internally, because it might be a thing that many of you guys would be learning graphs for the first time, right? So before jumping onto the question, what we would do is we would learn a little theory about it, and then we'd be beginning with the questions of today. Let me share my screen for that. Okay. I hope my screen is visible. Yes, it is. Just hold on. All right. So if I ask you guys, what do you know about graphs? Can you give me a very brief description in the chats? Anybody who knows what graphs are, can they give me a very little description about it? That's Pradeep. We will be talking about graphs today. Okay. You need to tell me what do you know about graphs? A very little one line explanation, a very high level explanation would work. I just want to know how many of you already know graph as a data structure? No problem. Random connected nodes. All right. Uh, Anyone else would like to attempt? Graph is a pictorial representation. Don't know where you can say that. Okay. It's a combination of edges and nodes. Great. Wiki has come up with the exact definition. When we are talking about graphs, what we actually mean is graph is a combination of nodes and edges. Okay. And nodes are sometimes known as vertex, VERTX, vertex. Don't be confused by that. I usually, most of the times, I'd be calling it a node. Okay. Non-linear data structure, yes, it is. And data structure consists of vertices and edges, right? We just had the example. Somebody is calling it nodes, another one is calling vertices. No problem. And we have said a diagram which has nodes and edges. We wouldn't say a diagram that would have nodes and edges. It is better to say a data structure which is composed of nodes and edges, in which we have you can say edges and the connection are not uniformly defined. Okay, it could be random. Let's see. So when we're talking about graphs, we know that we are talking about nodes and edges. For a person who is learning it for the very first time, right, Arshi? For a person who is learning graphs for the very first time, for them, very naive explanation could be, what are nodes? Nodes are nothing, but you can imagine them at a high level to be like these little circles with have some data inside it. Okay, so if I make it like this, these are nothing but these are nodes. All right, and what if I define a connection between them, assuming I connected these two nodes. All right, I connected these two nodes. Now, what is this line called? This is called an edge. All right, I hope everybody is understanding it so far. And if we put some random edges in between all these nodes, okay, some random edges, it'll look something like this. Okay, it'll look something like this. We can even have more nodes, all right, like this. Okay, so now we know how a graph looks like. How a graph looks like. All right, this could be said as a pictorial representation of the graph. All right. I hope the diagram is clear to everyone, and everyone now knows what are we talking about when we say node, or what we are talking about when we say edge. In the charts, say yes if you're clear about it. Better to say nodes store data and also confusion. Yeah, I'm just coming to that, Prateek. That is correct. Yeah. All right, Adarshi. Okay, so as Prateek already stated that I was about to, what happens is when we are talking about the edges, all right, when we are talking about the edges, if I'm saying this A, we have a node A and I have made a connection with B, that means that A is related to B, that A and B have a relation. Okay, so anything in the form of data having some relation can be defined in the form of a graph, can be represented in the form of a graph. Anything which, like any data, which has some relationship can be defined as graphs. What is the very famous example of graphs that we use in the real world? Maps, correct? In which we can think of our nodes as cities and our connections as roads connecting them. All right, this is how it goes. The very basic example that everybody knows and everybody takes. That let's think of it as a map where every node is a city and the paths are roads which are connecting them. Okay, this is the very real world example of graph, correct? Or It doesn't mean like this is the only one. You have so many examples. Again, we just said that any data, any sort of data, having some relationship can be defined in the form of a graph. All right. Okay. So once we have established this knowledge, let's get questioned with some more. All right. Facebook suggesting mutual friends as well. Yeah, that is also sort of a graph data structure going on. You have relationships, you have a single person, you have their friend, then you have their friend. This friend will be shown to you in your mutuals, right? This is how it is working. A transitive relationship. Okay. That's a thing of far away. Okay. So we are not going to be discussing weighted today. Okay. We'll be keeping it light because it is just 2 hour class. We are not going to cover whole graph like after this, you know everything about graph, but after this class, you'll be having a well grasp about what graphs is, and it will be acting as a head start for you to start learning deeper into the graphs. All right. Okay. Again, don't forget we do have questions to solve. Before that, let's quickly wrap up the theory. The first question is very easy, and when I'm talking about the theory, we can end up the first question here only. I'll tell you about that. But before that, let's talk about traveling this graph. Okay. So assuming you are standing here at A. All right. Now, can you tell me in the chats what are the possible ways or what are the possible paths you can take and you can reach the other node? What are the possible nodes you can reach to? In the chats, please, very quickly. Yes, we are going to implement the graph, Vicky. We are going to solve three problems of graphs. A, C, and E. A, C, and E. I'm just talking about the immediate neighbors of A. I'm just talking about the immediate neighbors of A. If you are starting at E, what nodes you can go to immediately? Okay, in just one step. Hello, Poonam. Good to see you back. One of the regular students. All right. Yeah. There are only two options. We can either take this path and go to C, or we can take that path and go to B. Correct? Maria is saying A, B, D, E. Okay, you are telling the past. I hope that confusion is clear. Now we know. I was talking about the immediate neighbors. Again, for the people who might not know what I'm saying when I'm calling some nodes neighbor, if A is here, the nodes that are directly connected to A are going to be called as the neighbor of A. Okay, so A has two neighbors, C and B, and those are the ones it can directly travel. Okay, from which we can directly travel. All right. Once assuming we are at C, now what options do we have? What options do we have? Quickly answer it. Yeah, I'm waiting. When we are at C, where we can go? Quickly. F and E. These are the two values we can go to, right? So we started with A and then we reached assume E. We have reached E now. Now, can you tell me from where we can go to E? Uh, from where we can go from E? All right. Everybody was saying F, G, and A. Okay, I didn't even have G till now. Okay, that's the end. Himanshu said C and D. No, you can't. I'll clear that doubt. Don't worry. Okay. All right. So half of the people have it clear in their mind. But just for Himanshu, let's say, for Himanshu and for other people who are not writing and might be having this answer, see, C and D are also connected with E, but the correct way of saying it could be C has a connection with E, but E does not have a direct connection with C. You can see the arrowheads. You have to move along with the arrowheads. All right. Once you're not moving along with the arrowheads, that means you are taking a illegal path. That's all. You cannot move back to C. You cannot move to D because the arrowhead is this way. And particularly when I've made this graph, I am talking about a directed graph, right? I am talking about a directed graph. All right. I hope it is clear to everyone what I've just told you, because clarity of these little things is very important, and it should be in everybody's head. The people who already know, it is just a basic revision for them, but the people who are starting with it must be very clear with it. I am waiting. You can type yes there. All right. Fine. Great. Poonam says something. If it is not directed, then we can say it is going to DNC. Yeah, then we can say it is going to DNC. Going to close that door with you. All right. Now let's make new edges. Now I'm going to make the same edges but without the arrowheads. Now again I'm going to ask some similar question and I want everybody to answer them. All right. Again, I'm standing at A. Yeah, Vicky, we are leveling up. Sorry for that. But just a second. After this example, I'm just going to come to the A list and we're going to see how we can implement in the code. All right. Okay, quickly, everyone. We need to get a little faster. Let's buckle up. If you are standing at A, just tell me the neighbors of A very quickly. Neighbors of A, very quickly. B and C. Right. We move to B. We move to C. Now tell me the neighbors of C very quickly. We are going to go fast. Tell me the answer for C. We have moved to C. F and E. All right. All right. Everybody who has said F and E are not paying attention. Yes, that is what I wanted to point out, and that some of the people are going to answer that. We saw this graph, this was directed, and when you were standing at C, you had neighbors F and E, but now there is no direction. But now there is no direction. You are standing at C, you have three possible ways to go. You can even travel back to A because there is no restriction of the direction, right? Correct. So everybody who has said A, F, and E, very good. And everybody who has said F and E, I hope now they know what is the correct answer, right? Now again, if you are standing at E, you have a possibility to go to C and D because there is no direction foundation like this we were having here. All right, this is what the doubt was. I wanted to clear for everyone. All right. Now let's talk about uh, how we're going to represent these graphs in form of a code. See, graph is not a similar data structure like your trees or we can say your linked list or stack which you directly declare and use. It is more of a concept. Okay, it is more of a concept, and we use data like different sort of data structure to implement this logic. And usually we do it by using two. We either can use a matrix or we use adjacency list. We are going to say adjacency list in this video, and you can explore the matrix one by yourself. This is going to take long if we are going to discuss two. We'll be taking this one because it is just just give me a second. Sorry for that. Let's continue. Yeah. For this, I hope now you know how it is working in a pictorial way. Now we need to see how we're going to represent that in agency list. So if I talk about agency list, in any of the language, you have some hash map sort of a data structure, right? Have some hash map sort of a data structure. We are going to be using Python. That means we can talk about dictionaries. That's all. Just the thing is, we should be knowing about this data structure. We'd be able to form adjacency lists out of it. Let's quickly construct adjacency list. So if I'm saying graph inside your code, it is going to look something like that. The very first thing, every dictionary or map has a key value, right? A key value pair. And we are going to use position of graph, confuse me. Vicky, we are going to be discussing one indeed and the other one. You can try to learn it yourself, and you can then while link the question, we can discuss it further. For this video, let's take this one. Okay, so let's again see if I'm saying key value pair, how we're going to use it. So now the thing, we can discuss if you have the audio issue. Is it breaking a lot? Okay, we need to figure out the voice thing. Is it fine now, or is it still breaking? All right, all right, all right, all right. I have no issues. Um, okay, let's continue. Let's continue for 5 minutes, and if then there is any issue, you can point me in between. All right? Okay. That's the thing that works as well. No problem. See, we were talking about graphs again. Let's concentrate here. No distractions anymore. When we're talking about a key value pair, how we are going to utilize to store this on this graph. Okay. Let's talk about the directional one first. If I have to define this graph, the very first step I would do is I would mark all the keys here. I would mark all the keys here, all the nodes here as keys. If I say A, I'm making key, and what is this? A is one of the nodes. I'll say B, C, D, E, F. All right. All these are my keys, right? And now, what are going to be the values? The values are going to be all the neighbors they have. So for the directional, we have, okay, completely. Very quickly tell me. A has B and C. I would want if you can write it along with me in the charts. B has F and D, right? And you can correct me if I'm wrong anywhere. C has E and F. D has E. All right. And E has nothing. That means an empty list. F has nothing. That means that empty list. Is this clear to everyone? What I've done here? Is this clear to everyone? What I've done here? Okay, fine. Srinivas knows it. Uh, let's talk about others as well. Everybody? Okay. Oh, all right, all right, all right, all right. Okay, I hope you understand till now. Again, if we talk about our undirected graph, we should know the values will change a little. Again, for undirected graph, we have A is connected to B and C, all right. B is connected to F, D, and A as well. And your C is connected to E, F, and A as well. Okay, your E is connected to C and your D is connected to B and E. Your E is connected to C and D, and your F is connected to B and. All right. Did you see what was what were the changes that I made in this graph to make it undirected? I hope you understand that. Yeah. Fine. Now, once it is done, let's talk about our very first question. It is going to be very simple. Okay. Before that, I remember one thing. In some of the questions, your vertices are given as a number so that you can assume if your vertices are given to be 5, what it actually means is all your nodes are from 0 to 4. All right. There is one graph where you have values 0, 1, 2, 3, 4. Because in most of the questions the values will be like this and your vertex will be an integer, we sometimes also use a simple list. Instead of using a hash map or a dictionary data structure, we can also use simply a 2D list in which we can have neighbors like this, and the index would be indicating of what node the neighbors are. I hope you understand me now, because the index would be acting as keys here. Basically, I hope you understand that. You understand this variation of the adjacency list? Yeah, it might be boring for some people, but believe me, there are many here who are doing it for the first time. So just for their sake, we have to get the pace a little slow. All right, Pratik. Anybody who does not understand should put no there. Okay. Okay. You have understood it. Right. All right. Great. Everyone else, please. All right. Fine. Hope everybody understands that. Now that we are clear with this question, clear with this concept, list cannot contain two values. No, list can contain two values. You can you can put the question in more clearer manner, Poonam. List can contain several values. If this is a list, it does not necessarily need to have just integer data like this. These could be integer, okay? It cannot be like it need not to be just an integer or just an character. It could be list of anything. What I made was a list of lists. Okay, list of lists. That was okay. So I have constructed a list that is of lists. So it is basically a 2D list, or you can say a 2D array. That's all. Okay. Ibri, can you put up the question in more precise manner? What did you not understand precisely? I'll repeat that again. I'm waiting for you, Ibri. Yeah. So till you put your question in more succinct manner, I mean in the data we can contain the vertices and the reference list. We would contain other list. Yes, that is the thing. I hope it was clear with the picture, but yes, specifically, these are all integers and these are all lists. Okay, so the dictionary that we are making, where key is an integer and the values are lists. Okay, how that is what you were asking, Poonam? Yep, fine. Let's go ahead. First, before that, let me give you the link of the first question. It is very simple, and I really hope that many of you are going to just solve it like this. Okay, I'm fetching the link to the next question. Just give me a second. Yes, Vicky, I'm referring to Python because that is a language I usually code in. And if you are like, comfortable with any other language, I suggest you the alternative of it because hash maps are in most of the languages. In fact, all of the languages. The thing is, you need to have a clarity about how the hash maps are working. That's all. Okay, I have given you the link of the first question. Click on the link, go to the question. I'm going to take a break of 2 minutes. Read the question thoroughly, and then suggest me what could be the approach of it. Or you can begin with first just telling me what did you understand by the question. Okay. The question is present in the chats. Please click on that question, go to the question, and read it. All right, people, I'm waiting here. I'm waiting for your response so that you can tell me what did you understand from the question. Okay, so I'll be presenting the question here. Yeah, that's very simple. It is just to print the adjacency list. That's all. This question is just to print the adjacency list. All right. I hope the question is clear. The question is saying you are given a graph in the form of a list, again, the way I told you. And what you need to do is you need to return a list in which you have the directions marked like this. That's all. So, yeah, direction marked like this. That was ambiguous. What I mean to say is you need to specify that 1 and 4 are the connections of 0, 0, 2, 3, 4, 0, 2, 3, 4 are the connections of 1, right here. Okay, and 2 has 1 and 3 as connections, 3 has 1, 2, and 4 as connections, and 4 has 0, 1, and 3 as connections. Okay, we have to return a list here. All right. I hope you can code it easily by yourself, but we are going to see the code. Before that, let me just illustrate that here. Okay, let's see. So if I am talking about a list that you would be receiving, it would look something like this. All right. Let me just fetch. All right. Okay. This is a graph. That means at the 0th position, we have 1 comma 4. At one's position, we have 0, 2, 3, and 4. And at this position, it will be 0, 1, 2. Just give me a second. Um, okay. Are you getting background noises? Just a second. All right. So we are continuing. Just give me a second. Okay. So once we have it here, uh, at the second position, you can suggest me the values till then. I have to. Okay. These are going to be the values. For 3, we have 1, 2, and 4. And for 4, what do we have? 0, 3, and 1. 0, 3, and 1. Right? So I hope this is the input list. What do we have to return? We have to construct one more list, right? And we have to just say what node is there and what neighbors does it have. It has 0, 1, 4. We have to construct a list like this. It has one has all these connections. We have to write it like this. All right. Just similar thing goes with every other block, every other value. Did you understand the question? It is pretty simple. It does not actually have any explanation. Is it clear to you? Is it clear to you guys? Quickly. All right, Arushi. I need more answers from there. Yes. Fine. And even Srinivas, I think you code in Python, right? You can write a one-liner solution. It would be helpful for everyone. Or I have to go ahead and write solution. Let's write it. All right. Everybody has understood it. Okay, Vicky, are you asking something? Vicky, if you are asking something, you can put on the question. Okay. Till then, let me tell you how the code is going to be. You can do two things, right? You can create up your own list, and then you can keep on making a list like this, right? The first option is this. You can traverse the whole list, and at every index, you can proceed with it. You are not getting the points. Okay. Okay. Let me tell you. Did you read the question? The question should be clear. The question is giving you this graph and is asking you this list. That's all. You have to add up whatsoever node there is. Okay, we have just talked about this representation. This thing means that at 0 node we have 1 and 4 as connections. At 0th node uh, we have 1 and 4 as connection. From 0 we have 1 and 4 as connection here. From 1 from 1 we have 1, 2, 3, 4, or sorry, 0, 2, 3, 4 as connections. This is what we are given. What we are making, we are appending, or you can say we are putting this value, the node here at the first. That's all. This will become 0, 1, 4. This question is not even a proper question, but just for the sake of it, let's solve it. Okay, you have to append this one here at this list. Okay, and just you have to do on like further on like this. So 2, 1, 3 will be the next block. Next will be 3, 1, 2, 4, like that. All right. Yeah, you have to create an array of list type and store the list of zeroth node neighbor and then value. Yes, 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 yes. You have to do that. Yeah, yeah, you can do that. Completely fine. But you know what would be even better? Why even, why even, yeah, a better way of doing it, right? But why even make changes, or you can say, why even make a new list? We can do the same thing in the adjacent list that we are given, and we can return that without using any extra space, right? Srinivas, one liner, always is. Great. So let me just remove this screen, and we are going to be coding it very quickly. Let's go for it. I'll just make the changes to the adjacency list that we are given as a parameter itself. All right. So let's start the coding. We can simply say we have to run a loop on this ADJ, right? Now we have to insert the element, the position element, which will be beginning with 0. So we can either take a range of it or we can simply define another variable. If I'm not using enumerate then. And then we can say the I would be the list inside the list itself. So I can say I dot insert. The first parameter is going to be where we want to insert it. That means X. We want to insert initially at 0. And comma, what value do we want to insert? We want to insert. Okay, 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 okay. Just a little confusion. What was the first value? Can you quickly tell me the parameters of insert? Because that's slipping out of my mind. Let me check. Just give me a second. The first is the index, and then okay, okay, okay. Because all the time yeah, first is the index. That means we will be appending it from the beginning, right? And the zeroth index every time. What value do we want to append? X, because that is a node, right? X would be firstly your 0, then we'll increase it accordingly. Yeah, thank you for confirming, Srinivasan's side. Yeah. So what we have to do now, I have to just increase the value of X by 1. Done. I hope this would do. And simply, we have to return the ADJ now without using any extra space. We did it. All right. Okay. So the output is printing as the way it has to be. It should be. Okay. Yeah, it is getting solved. All right. So that was our first question. The second question is again one of the classics. So I hope you, like, till now, you are with me and you have understood all the things that we have discussed so far, from the very basics of the graphs till solving this just a question. Okay, no need to mention 0 either, I guess. By default, if it is 0, no, I don't think the default is 0, is it? I need to check. If the default value is 0, okay. If it is getting inserted at 0, then it's fine. Um, all right. Thanks for the extra knowledge, Sahil. Poonam has understood it clearly. Great. I'm asking about all the other people. I know the active ones are here. They are going to reply to me and they are going to make this session very engaging. But what about all the people other than those? Other than those, I am able to see you guys, but I'm not getting answers. So yeah, we are going to be continuing. Everybody, just quickly tell me if you have any confusion till now, from the very basics of what graph is till solving this first question. All right, let's go to the next question. I'm going to be giving the link. Okay, here it goes. You have the link in the chats. Now, what you have to do is you have to read the question. The name of the question is detect cycle in an undirected draft. Okay, go ahead and read the question. Then the question is pretty clear by the statement, but still go read it and tell me the approaches that you can put with this question. No problem, Divya. If you are joining it from today, you can keep on continuing for next 9 days that we are going to have, and you can see the older streams. The old streams are available. Don't worry. All right. I hope people have started reading this question. I'm going to present it on the screen so that everybody else who is unable to open it can read it. Just all right. Here's a question. Given an undirected graph with vertices V and edges and E edges, check whether it contains any cycle or not. Graph is in the form of adjacency list where ADJI contains all the nodes ith node is having edge width. Okay? No cycle. That is not the case. Don't worry, we are going to discuss that. If if two nodes have a single edge, then that doesn't mean that it is a cycle. One connection is needed to be there. That means by that logic, every undirected graph would be connected graph, would have a cycle. One, so same one and another for detecting the cycle. You can elaborate more on how you're like what you are going to maintain the visited node, the second visited for. Cycle the graph, like if we start from one, so we were ending on one, like one, we're traversing other nodes. So it is a cycle, otherwise not. Okay, okay, lovely. We're gonna see that. That is the correct approach, but it needs improvement. It needs improvement. Anyone else would like to attempt? What is unconnected verse therefore? Unconnected means like it is not having any connection with any other node. It is just a vertex line. Okay, the second input you might say. See, that is just to check like if your program is going to work with this or not. Because you, whenever you take up a graph problem, do not just go by the you do not just go by the edges. See, you traverse each and every node, right? Even if you are given a list, you're going to go to each and every key. So it is up to you. If one node does not have any key, then it's fine. So we keep our visited nodes, and if it comes again while going in the graph, then there's a cycle. Yeah, that is the basic statement, but it requires a little modification. I will tell you where it is going to fail. Don't worry. We'll make a little modification, then it will be completely fine to go. It is just very basic DFS problem, very basic DFS problem. And people who have been joining these classes, they know how a DFS works, and they would catch it right away. Yeah, everybody saying the same thing. We can move ahead to the solution. All right. Well, let me fetch the example from here. All right, we have this example. Uh, Looking well, I'm going to draw it. Yeah. Oh, it is like this. Now let's again do the traversal that we were doing. We are here, and let's think of it as DFS. Okay, we have to make one choice. Well, we only have one choice here. We'll go to this node now. Okay, from here we are going to go to this node. All right, that means the traversal is done. Can we use DFS to decide? We need to think of one approach for that. Perhaps see, most of the things that you are doing with DFS are most often possible with BFS as well. All right, so there should be just your mind clicking for the iterative version of it, because I believe it is easier to think of a recursive solution than an iterative solution. All right, because this is the path where we have learned recursion and backtracking, then we are coming up to trees and graphs. We are actually focusing upon how things are going in this manner. All right. Again, now coming back to the graph, uh, yeah, if we are traversing it in a DFS manner, we are going to take one under consideration. Once that is traveled, we are going to go to two. Once two is traveled, we are going to go to three, right? And these all nodes are traveled. Once three is traveled, I will go to four. From four, we have one option here. We'll see that this node is already visited. We can say that the cycle exists, right? But is it the right way? What could be the loophole in this approach? Would anyone like to suggest what is the loophole and what is the correct way? Again, just to mention, we have this graph to be undirected. All right. When there is undirected, two's neighbor are one and three both. Correct. So once we are ending up, there is a possibility that once we have traveled one, two would be here. Two can make this choice as well. It will say that yes, one is already visited and we are here to visit it again. This condition came, you will say that cycle is present, but actually it was just two nodes connected. This logic will also give, we can use a listed boolean array. Yes, surely we can for maintaining listed. See, this is what you guys are doing. Only a single connection is made between these two nodes, and you will say that this is a connected graph. According, if this was the input to your logic or to the logic that I've just discussed, this will also be a cyclic graph, is not, which actually is not a cyclic graph. All right. If we, it'll put true for the first edge itself. Pretty right. Yep. It'll just say that it will just say that these, like this connection also is a loop. This is a loophole of the approach that we have been thinking so far. What could be the modification? I am waiting for the suggestions because I want you guys to brainstorm. All right, the discussion is open. Everybody else is able to see each other's comments. That's why we have to take two listed arrays. Yeah, that is the thing, Srinivas. We have to take two listed arrays, or we can think of something even better, even lesser space, anything like that. All right, we will we can discuss everything in the chats, right? Related to the question with each other as well. Come up with the approach. I'll tell it. Okay, but I want you guys to come up with the approach. Srinivas has already given his approach. Okay, we need to perform DFS on every node. On every node, what do you actually mean by that? Because we would be traveling like the every node in one DFS as well, most probably, depending upon the graph. Okay, you might be saying that we have to call the DFS on every node, right? We don't need to do that. Don't worry. Okay, Srinivas is the only one who has been suggesting. What about everyone else? They should be capable enough of suggesting things now, right? Ranshu, Arushi, where you guys are. Poonam, don't you have any suggestion to make? Tej, Sahil, I hope that everybody that proposed a previous solution now knows where the solution lies. We'll go on the forward direction, not backward. Once you are inside a graph, you cannot see which direction is forward and which is backward. You cannot detect that. Green colors like white, black, and gray, that could be visually possible, but for like maintaining it, that would require a little code, which would go a little on the tougher side. If the two words contain more than one, if two words contain more than one same node, what do you actually mean by that, Sahil? Please explain me. Nodes. See, very simple. What we can do is, what we can do is, we need to track that once we are visiting in a DFS manner, we are not we are not going to the parent. That's all. That's all. We are not going to the parent. Replace with some just same number of nodes greater than three. Then yeah, we can do that mathematically. It could be a better option if that works for every graph. But right now, you can try the solution directly in your code stub, and if it is passing every other test case, you can confirm it here. We'll discuss it. Okay. But for the time being, because we are talking about DFS, let's keep it to it. Now, what we have to do is, let's see, we need to take care of the parent. Now, you might say that graph does not have parent node. You're correct. Trees have parents node. But I'm talking about the calls. I'm talking about the calls. If you are here at zero, you have your just a second, you have your DFS being called by zero. This is making a call to one. Now in this situation, in this tree, the DFS one will make the call to DFS two. In this situation, we can say that this is the parent call and this is the parent call. Can we say that? Yeah, Arushi, DFS is going to be the solution. Stated assisted. All possible immediate neighbors. Yeah. All right. I hope now you're getting it right. We can say that this call is made by this, thus this is the parent, thus this is the parent, right? Like that. So we need to take care of the immediate parents. That's all, nothing else. It is just the basic DFS. But there will be two conditions. Okay, what were the two conditions? We have made DFS for matrix generally. For that, we were checking that if it is valid or not. That means it is inside a matrix or not. We do not need that condition here. We just need to check that if it is not already invested, if it is not already invested, and it is not the parent. That's all. These are the two conditions. You're going to check it, and the DFS is going to be completely the same. Completely the same. It is not going to be having any other variation. It will work. Only one condition is increasing for your DFS to run. When you were making the calls, you were making the calls when you had one unvisited path. You just need to check that the path that you are going to is unvisited and that is not your parent. That's all. There is like only one condition that we need to put, and then it'll work. Now again, I'm going to give you 2 minutes more to do or think of the implementation yourself. Then you can write here in the comments what did you understand, and then I'll go forward and tell you the way of writing the code, and then we will discuss the code as well. All right, I'm waiting. How will we define Try that, Vicky. Will be in terms of code. We are going to see that code. Don't worry. We are going to see that. We can just keep on a variable, and for every call, we can say, uh, okay, we will be passing one more parameter. Just I talked about. You can name that parameter or variable as parent. Once you are making a call, you should be well aware that of what node you are making the call from. Pass it as a parameter. That's all. When you are standing at one and you are making a call to two, add one more parameter, pass one to it. That would be the parent. As simple as that. Yeah. All right. So I hope you have figured it out. This should happen also. Yeah, Pratik, you guessed it. Should I start coding now? Plus one in the chats for me to begin the coding. All right, Srinivas is always ready. What about others? Manju says yes, we can go ahead. And all right, says that we can go ahead. What about others? Are they ready or not? Pratik, Poonam. All right, Pratik is ready as well. All right, let's go to the coding window. Okay, all right. So we have to code it in just the way we have been coding a usual DFS. That's all. So for that, what we are going to do, the very first thing would be making a visited set. Okay. So what I was saying, if we go to each neighbor, if we go to each neighbor, each node, DFS. Himanshu, once we end this question, before taking the next one, I'll clear the difference between DFS and DFS. All right. I should have initially. Let's do it. Let's code now, then I'll tell you. All right. So very quickly, let's start coding. Once we have created our set, then the next thing that I would need is a loop to make the calls, correct? Because whenever we are in a graph, we need to call from each and every node, right? And we need to check that if one node is already vested, you're not making the call from there. This is because the graph may be present in a manner that it is not whole connected component. Okay. It might be broken down into different components. That is also a sort of graph that we might have. So just for the sake of it, we make one call, then we go to the DFS, we explore one part of it completely. Then if if there is any chance that there is any other component left which is not connected to the first component, because of this loop, we would be able to access that as well. I hope that made it clear. Let's begin the code. So for I in range, what do we actually need? We need V. We have gotten V already. So we can either do len of ADJ, that would also give the same thing, or we could do range V, completely the same. Now I'm going to check that if I is not in visited. So I'm just going to say if I not in visited. All right. What I'm going to do, I'm going to call the DFS. DFS for me is going to be a Boolean function. We can discuss it for a while. But for me, DFS is going to be a Boolean function and it will be returning a true or false value to me. So I'm calling it in this manner. First thing is going to be I. I means the node that we are standing on right now, and we are making the further calls from. A, D, J is your graph, and the next parameter I just told, obviously, it is going to be visited. For the time being, because we have to send one parent, we cannot just send it like that. Let's create a run like the very first parent for the source node to be -1. Okay, it's a random value. Now we are going to check. Now we are going to check that if the result is there, if we are getting the result, that means if the result is true, then you simply say return true. That is the answer. Right? What if we are not getting true? We are going to make further calls. That's all. Once we have exhausted the whole graph, we are going to return false. Once we have made calls to each and every component of the graph and there was no result, then what we can do, then we can simply return false. All right. I hope everyone now got what I wanted to do. The design of DFS function is still left, but I hope the main code is clear to all. Is it? If anybody has any doubt, I can repeat it very well. All right, people in the chats. All right, I'm waiting for you guys to tell me if you have understood this main problem, the main code. We're going to design the DFS further. Good to go. All right. Okay. Now let's make the DFS function. For the parameters again, it was I, then A, D, J, the graph that we have, and then we have the visited -1y. Okay. Because for the first node, when you're starting, no, minus node is nothing, just a default value that I've given. So from wheresoever we are starting, it might not have any other like any previous call. Okay. From the if you are standing on 0, you're already standing on 0. You are going to call DFS from here. I showed you the DFS calls, right? The very first call, DFS 0, does not did not have any parent to it. So just because it did not have any parent to it, I have given a default value of -1 for the initial call. That's all. All right. So the last parameter is going to be of parent. All right. These are the four parameters that we need for this DFS, and it is going to be completely the same. What is the first thing? Just dot add. We mark the node as visited. What do we What do we mark as visited? I, because I is the node. Now I'm going to go to each neighbor of I and make the call. So for that, I'll just say for I, uh, let's change the variable. Okay, for neighbor in A, D, J, ith at the ith index. That means of the ith node. This will give the list of all the connection that the ith node has. All right, now I'm inside it. I have to make the calls. For that, I have to check if the neighbor is not in visited. First thing to check, the very initial and the foremost thing to check is this. Then if it is not, I'm going to make up the call. I'm going to make the call. And because that function is basically a Boolean function, I can make the call like this, right? Now, for me, I value is going to be changed to the neighbor because now we are proceeding further in a DFS. So I'll do it neighbor, comma ADJ is going to remain the same, or Viz is going to remain the same. But now, what is going to be a parent? Tell me, what is going to be a parent? In this parameter, what I'm going to pass quickly in the charts. Anybody who is attentive is going to answer this. The last parameter parent, what it is going to be? According to this node, what I am going to write there? As a parent, what we are going to write? What is the neighbor's parent here? What is the node's parent here? All right, I'm waiting for the answers. I, correct. Pratik has answered it correctly. Poonam too. All right, we are going to pass on I as a parameter here. And if that works, I'm going to return. If that works, I'm going to return true. Now is going to be the condition that I'll check. Now is going to be the condition that I'll check for parent. If the parent is not equal to neighbor, if the next neighbor that we are visiting to is not our parent. If we are standing at 2, we have come from 1 and we are standing at 2 and we are again going back to 1. What we are checking? 1 is the neighbor, but we are checking if it is not the parent as well. Right? So now I hope you get it now. We are just going to make a check. And now I can say that if this is the case, then I can return to again. And if nothing like such happens, and all the calls get exhausted, I can return false. It won't require any base case as such because we are not actually uh, stopping at any particular point. We are stopping when the values are exhausted. That will be taken care by the for loop because it will only run when ADJI has some values. If it doesn't, it won't run. It will simply return false. So we do not specifically need any base case here. And because this is a normal DFS function that we have to code like that we have to just go for once only. We do not have to backtrack it. That is why we are not unvisiting the node. Yeah, because some people might have been thinking that why that step is missing, because that is a backtracking step. That once you mark a node visited, then after going back, you mark it unvisited. That's a backtracking step. And here, we're not doing the backtracking. We are simply just going in for the first time. We are traversing the whole. That's all. This is how it will be done. Now, let's quickly check if it is working. First of all, I think if the neighbor is not in visited, then we are calling the DFS. But if the neighbor is in visited, yeah, sorry. If the neighbor is in visited, then we are going to check this parent. It is parent or not. All right. Done. Fine. And it is not okay. I hope the conditions are clear with you. If it is if it is in visited and it is not a parent, then the cycle is there and we're returning. All right. Okay, guys, let's run it. Yep, it is working fine, no problem. Let's try submit that. All right, it is submitting well. Okay, now does anyone have any sort of confusion in this question? If they have any sort of confusion, they can tell me. If they have any sort of confusion, they can tell me right away in the chats. or if they understood the question, they can write +1. All right, I'm waiting. Sahil, I hope now you understand why that was -5. Correct? All right, Srinivas understood it, but I require answer from more people. Understood. I will try to write in Java. As you wish, Poonam. Sure you can. It's the optimal approach. We could even find do some mathematical approach to it. I still have to look into that. Well, this was the thing that I was doing, and it because okay, let me tell you, the question was asking for. I have not discussed the complexity as such, but just because you're asking, okay, this could be one of the very best approaches because in any of the graph problem, if we have to traverse the graph for only one time, that is an optimal approach. Because to figure out anything, you what you at least need to do is you need to go to each and every node. And this is what we are doing here. We are not making the repetitive, what do you say? We are not making repetitive iterations. We are not making repetitive traversals. We're just going in for the first time, and we are getting the answer. Thus, the time complexity is going to be O V plus E. Big O of V plus E, where V are your vertices plus your edges. That is the most that you are going to travel. That's all. I hope that cleared your answer, Pratik. That cleared your question. The answer was well. All right. So, what about other people? There were many. There are many right now. What about others? Did you understand the second question? Did you understand the second question? All right. Maria has understood it. Fine, guys. So now we are left with the third question. But before that, somebody was asking about DFS and BFS, and because I missed it in the initial part of the video, let's quickly cover it. It might be again, it might be boring to some of the people who already know it, but because we have to keep it basic and everybody here should understand that, let's do it. Okay, instead of this graph, let's take the other one. That would clear your doubts in even better manner. Okay, till I'm drawing, all the people who might be wondering what I'm doing, I'm just creating up a graph structure. I can show you how DFS and BFS actually work. Well, DFS stands for depth first search, and BFS stands for breadth first search. We are going to explore both the ways of traversing a graph. Both are basic traversal algorithm for a graph. Okay, all the people who have been attending the sessions might already know from the BFS class that how these two things are working. From the backtrack. Okay. Oh, it is taking a little longer. Sorry for that. Okay, once we have this structure, assume once we have this structure, and you are here at this node. Okay, DFS means go to the depths. That means you keep on moving in one single direction until you cannot go in that direction. Then is the time change your direction, then keep on going to that other direction. All right, just give me a second. Just give me a second. Okay, was the screen not presented? somebody should have commented on that. I was thinking that the screen was presented. Sorry for that. Just give me a second. Right. Okay. Now it will be clear to everyone what I was doing. Any such situation occurs, then I'm just talking. Okay, now Puna wrote not visible. All right. Fine. We are here. Sorry for that. Okay, now that we have it here, I was saying that if you are here at this node, okay, and we are performing, what does that mean? DFS means depth first search. That means we are going to be going in a single direction till we are unable to go further in that direction. Then is the point that we will be changing the direction of exploring the nodes. Okay, so if I talk about DFS, and I am here at this node, and let's talk about the cycle. These are the four possible direction I can move from if I'm standing here in center. Let's keep the cycle to be like this. Okay. So I'm going in this direction first. So if I move to this direction, this will be my next node. Again, I'm going to go in the same direction. This will be my next node. This will be my next node here. Can I go further in that direction? No. What is the next direction I have to go? Down. I'll take this direction. This, this. Now, can I go further, go down? Like, can I go down further? No, I cannot. The next direction is left. We are going to go like this. Okay. This is how we are traversing. Now, again, we cannot go further towards here. We have to go up now. So we are going up. From here further on, can we go up? No, we cannot. Right? No, we cannot. Now we are going to go to the back because we are not able to travel it. So now the thing is, we have to take another path. We take this, we take this. This is already visited. Then what is the path that we'll be taking? After down, it's this. We'll move towards here, then again. Not visit, like this is visited, this is visited, this is empty. We're gonna go here, we're gonna go here, just like that, till we can go up. Then again, we end up here, right? Now we cannot go further. This is how, I hope you get the idea. This is how you will be traversing in a DFS, right? Now let's quickly talk about the BFS so that everyone has the clarity in mind. Who was asking about DFS? I hope it is clear to him. Whosoever was asking about it. All right, people, is it clear? Is it clear what I actually mean if I'm talking about DFS? To the ones who did not know it actually, not about everyone. Okay, again, if you are standing here at this node and you are talking about BFS, then BFS means that what you do, you stand on a single node, you explore all of its neighbor. Okay, and you pick up each neighbor and explore all the nodes of that neighbor. Okay, if you are standing here, that means this is visited. You need to visit this, this, and this, right? Then you will take up nodes. This was visited. We are going to visit all the nodes of this node. This, and this, right? Then we have this to be the next node. We will visit all the nodes of this. This is already visited. This will be visited. This will be visited. Now this node, this is already visited. This will be visited. This will be visited. For this, these two are visited. This will be visited, right? Now this was the node that we were working on. So for this node, this will be visited. This will be visited. Again, for this node, no, coming to this node, this will be visited, this will be visited, and further on ahead, like this. I hope it is clear to everyone how BFS and DFS work. This was a little more effort and might be, very easy for some of the people, but whosoever was asking the question, I hope it is clear to him, right? For tomorrow as well, you are going to be having the session of the session of graphs, and then further on, I believe the next lecture are going to be for DP. Okay, it's a total. All right, let me drop in the third and most interesting question of all. It's going to be a homework problem, but we are going to discuss what the question is talking about. We are going to be talking about the approaches. Don't worry. That, let me give you the link of the question. All right, there is the last question that we are going to discuss today. You have to write the code on your own, but we'll be discussing about what the question says. I'll make you understand the question. I will give you some little hints, and then you have to code it on your own. Who will come tomorrow? You or Siddharth? I will be coming tomorrow, and tomorrow is going to be my last day of this series. And then from further on, some the next month I will be taking it. Maybe Siddharth, maybe Jay. Right? Poonam? Fine. The question is given. I'm taking break of 2 minutes. You need to go read the question and then tell me what the question says. Poonam, well, that was the plan of the session because we have 21 days straight, and I don't think that every mentor is free for straight 21 days. So we will be having combination of mentors. And for this particular session, I think four mentors are there, including me, that are taking the sessions. But I hope that what we are doing is we are going very topic wise, so that when a new topic is beginning, then only a new mentor is going for that. We are not breaking the flow. If graph is going on tomorrow too, I'll be taking a graphs class. Okay, if trees were there, I completed the trees. This is how it is going. Yes, Arushi, that's the question. That's Priya. All right. Now, have everybody read the question? Has everybody read the question? You can give an acknowledgement there in the chats. All right. Arushi, have you read it? Srinivas have read it. Lovely has read it. This is very well. Very well. All right. Okay, I hope the problem is visible to everyone. Didn't get the question. Don't worry, Poonam. We'll discuss. All right. So, assuming this is your question, all right. This is your graph that is given as a question. We are needed to find out which nodes are actually the articulation points. Okay. So, what do I mean by articulation points? Articulation points or articulation nodes are those vertices which, when removed from the graph, will result into two separate components of graph, two or more. What do I mean by that? Let's see. For here, 4 is one of the articulation points. You need to think that if you move 4, there would be one component that would be 1, 0, the other would be 3, 2, right? The graph will be divided into two parts simply. What node you have to choose that when removed will result in two or more graphs. That's all. All right. That is all. Has everybody understood the problem statement? I'm waiting in the chats. Has everyone understood the problem statement? All right. See, people, this is a very tricky problem, and this is going to require some of the new concepts. The problem is directly given to you, but you should have learned what bridges are. I'm going to tell you what bridges are, and then how we approach that. I'm going to tell you that. And for this question, then further, you have to use your own brain when we are discussing bridges, how we are going to relate it with the articulation point, and then you need to go further, solving the articulation point. All right. Let's do it. Okay, coming to this. Let's talk about the graph. Okay, assuming this is a graph, let me give some values so that we can name it. All right, assuming this is a graph, the question is about articulation point. That means we have to find out the articulation node. But let's first discuss how we can approach this question if we are talking about edges. Okay, if you're talking about edges, the question will be will then be what edge we can remove so that the graph left is has been separated into two or more graphs. As simple as so. In this problem, we can clearly see that this edge, the edge DF, is the edge that, when removed, will result in two separate graphs. Correct? How do we approach that? Can someone tell me? We have seen how we can detect cycles. We have seen how we represent lists. Now, for this one, can anyone tell me what could be the approach? Anything coming to anybody's mind? Any solution you want to suggest? Any Any intuition that you are getting that this problem will be solved if we do that, tell me in the chats. We have plenty of time to discuss. I'm waiting, people. Again, if you're not getting any of the intuition, you can mention it there. I've approached for every edge or node we remove and traverse the remaining graph, BFS or DFS. All the nodes are not visited, all in one component. Yeah, but that would be very complex because we have to do that for each and every edge, right? We can have like so many edges, right? And even after doing that, we need to perform a BFS or TFS as well. It is going to be exponential. We need not to go with it. We have to come up with a smarter solution. We have to remove such node like their node does not connected to the other node. We have to elaborate that a little more, Poonam. Yeah. Okay, I'm going to give you a hint of this. Then we are going to end that. You need to take that hint, go, search, look for the approaches. Then you have to try to solve that. Okay. There is one famous algorithm that we are going to be using. For that, we need two things. We need to maintain count number of edges. Yeah, further on, we count number of edges, then remove edges not part of a cycle. A cycle, remove one edge, not part of a cycle. Okay, all right, all right. By okay, Arjun is saying she has studied, but she doesn't remember that anymore. Don't worry, happens with everyone. See, because of this particular example, you might be saying that Pratik, but there could be more examples. I have made it in such a way that it is looking like so. Remove a couple of edges, let's say this and this. Now, what is going to be the answer? Will that be same if I even construct some of the edges? Like I am not removing this one. And, okay, let it be. Let it be like that. We want some dense graph in it. TVQ, let's say. That is why you should. All right. See, let me tell you one hint. Okay. For this graph, for this problem, what you need to do is firstly you need to solve it for edges, and then once you are comfortable with it, a little bonus step is going to be your solving for your vertices. Now, what do we mean by that? We need to do that. Like we will be doing that in one iteration, possibly, hopefully. What do we need to do? We need to maintain some like two data structures. One is going to be your time. One is going to be your time. Another is going to be your least time. What are these two data structures? Let me define it for you. I'm going to give you the definition of these two data structures. And then you have to guess how you can utilize these to solve this question. I'm not going to completely tell you the approach, then it would be not of any explanation for you guys. I'll tell you how these data structures are working, and you need to figure out it on your own, that how you can use these data structures with this graph, with your DFS call. Again, I'm giving you one moment. There's a simple DFS again. Okay, simple DFS, but you have to make some modification and include these data structures in your conditions. You have to maintain these two data structures, and then according to these two data structures, you need to again figure out your calling part about like after what conditions you are calling. You figure out the conditions from there. Okay, what is time? If you are beginning from here, your time and your least time both are going to be one, right? And we're talking about DFS. If you go to B, your time and your least time are both going to be the same, right? Then you go on, let's say to T. Both the things are going to be same, right? Your least time and your time. Then you're going to go to E. You'll say the time is 4, the least time is 4. But then you'll compare A. You will see that this does have a connection. This node is already visited. So cannot I come from here? I can, right? And when I compare, what is going to be the lesser value? 4 or 1? 1 obviously is going to be the lesser value. What we will do, we will change this 4 to 1. All right. This is how we'll be maintaining time and least time. You need to now figure out how we can use that to figure out this problem. I'm going to give you this as a task because if we discussed it, the whole essence of this question will be lost. All right. So we'll be taking a hold. Okay. I hope I've given you the hints properly. You are now going to explore these hints. You are now going to know how these two arrays or these two lists that you are maintaining, how they're going to help you in solving this question. I'll give you enough of the links. Again, I have given one more link, one more hint that this is just going to be, again, get your DFS, but a modification. All right. Now, I'm here, I'm open to all your queries that whatsoever we have had in this class or the previous ones that I've taken. If you guys have any problem in that, you can post it down here. Or even in general, if you want to talk about something, I'm here for 5 minutes more. In the chats, please. Suspense. Yes, it is suspense. Yesterday, I was meant to hold the question as well, but I gave out too much. When I saw the video, it was almost this time you are going to tell me tomorrow that how did you approach this question. All right. Now, what about everybody else? Have they enjoyed the class? What about the people who saw graphs for the first time and were able to understand? Because I know there is some audience like that always. I'm waiting for the responses. Are there any? If you want to talk, if you want to comment, you can chat here or like about whatsoever you have been doing in the 21 days. I think everybody is just thinking about the problem, right? That is good. Everybody is thinking about the problem. All right. Any draft algorithm you suggest? Session before tomorrow session, if you, yeah, okay. I'm not supposed to reveal the questions first. You might actually have all the questions by yourselves, right? Okay, so for tomorrow, you must go through Dijkstra. Okay, because we'll be talking about that. DFS, you guys are pretty comfortable with DFS. No problem in that. You guys should just look at Dijkstra algorithm first. All right. I hope that was helpful. What about everyone else? Have they understood today's class? Have they understood the basics of graph? Was the motive of this class achieved? I'm asking to all of you guys. Srinivas is there, Arashi is there, Poonam is replying, Pratik is replying always. Today we actually today we had so many active users. Maria has been there from yesterday's class as well. Okay, people who have been like who are being continuous are increasing. Sahil, I remember it from the last class. All right, Anshu too, he has been following. Yes, it was just as fun. Thanks, Pratik. You are one of the motivator here who always do not forget to put a comment. Thanks for that. Thanks, Srinivas, and thanks, Arushi. All right, so I'll be winding up the session now. Again, some of the requests from you guys. It would be best if you can like the videos and you can go write down comments after the chats so that it is visible because I go through it and I obviously get motivation from that a lot. So that is fine. I'm going to be ending the session now. Be prepared. Tomorrow is going to be my last session for this whole series, and we are going to be having as much fun. Don't worry. And then we then you are going to be beginning with DP. It's also a very interesting topic. Why can't we have meetings? Because there are very less people who really tend to join Zoom meetings. I can suggest that we like for the next 21 days, whenever we come up with or any other thing, we can do a simultaneous thing, a YouTube live plus a Zoom. I can suggest that. I'll take the suggestion, Srinivas. It would be even better. We'd be able to talk face to face, right? Okay, now Rupa is saying I missed the previous session. No matter, the session is already recording. You can go there. You can see the session, and tomorrow is going to be the class I'm going to be in. You can ask the question if you have any. They will be available for 21 days too. It is going to be a series in the YouTube, and it is going to be available to you. In general, is craft DPR tough topics compared to tree? Not DPR graph. Happens with so many people, Poonam. You are not the only one. But if you have good grasp over trees, graphs are just a little more like modified trees, you can say. Okay, but you can even say that trees are more restricted. Graph do have some like freeness as well. But with freeness, you need to control that, and you need to have a little more typical algorithms. But once you are done with the classical algorithms of graph, no question will seem big or tough to you. Talking about DP, we are going to be having three straight sessions just for DP, and I think Siddharth is going to take that. And I really like, I know how good he is in his work, in his craft. He's going to completely make you feel how DP works, and he is going to make you fall in love with directly. Don't worry. All right. So all the audience that we have today, thank you for being here, for being very interactive. Like out of all the 4 days, today I received the most number of replies. For tomorrow too, I believe that yeah, men and women perfect. So for tomorrow, it is going to be as much fun. Hopefully, we'll be meeting tomorrow, and then let's see. All right. Okay. I'm saying bye now. You can reply in the chats, and then we'll be ending the session. Okay. See you tomorrow. Bye, Srinivas. Bye, Poonam. Bye, Prateek. And who were the people? Good night. Who are the people who are answering continuously? Arushi and Malia and Lovely and who was more? There was one more person, right? Who has been regular. Sahil. All right, and Imanshu too. Thank you guys for being regular and for making the session engaging. All right, see you soon. Bye bye. Don't forget to comment down and don't forget to like. Don't forget to subscribe our channel. Bye bye. See you tomorrow.